What you think of
Okay, so you tell me, is this Exhibit A, Exhibit B?
well, like B.
A, B,
Yeah.
what do you want?
B.
B, all right. Okay, so let's have a look here. This is, we're gonna look at adding and subtracting rational expressions. So what do we talk about? We talk about simplifying rational expressions by factoring and canceling like factors. We talk about multiplying and dividing rational expressions, which is really the same thing as simplifying. When you multiply straight across. And so everything on the tops of all the fractions just goes into the top. Everything on the bottom goes into the bottom, and then you factor, continue factoring and cancel like factors. When we add or subtract, it's a little bit more complicated actually, because you have to get a common denominator. So what I want to do, I think a good way to approach this stuff is to think about it in terms of numbers. And then we'll just take our thinking with numbers and we will extend that to algebra. Okay, so let's just think about some fractions, just stuff we would have done back in, middle school, maybe even, probably middle school, maybe even elementary school a little bit. How do when we want to add up something like 2/9 and 7/12, we've got to find the least common denominator.
I first find the greatest common.
Say it again?
Nothing.
So what is, you guys can probably tell me, what is the, no? 36. Now let me address those two questions because it's really easy to confuse these two processes. When we're factoring, we're trying to break things apart into a product of small things, right? And we've been doing a lot of that. And so a common factor of 9 and 12 is 3, right? That is the greatest common factor of 9 and 12, the biggest thing that divides into both. But when we're trying to find a least common denominator, that's not a factor. We're trying to find a multiple in this case, is the way you typically would think about this. We'll look at this in a different way also. But you're trying to find the least common multiple of 9 and 12, which is 36, right? How'd you do that, Derek?
I don't know, I just knew it.
You just knew it. It's kind of an invisible process that's running in the background of your brain, but I bet you money this is what you did. I bet you money that subconsciously you considered a list of the multiples of 9 and 12. And you just found the first one. So what would a list of the multiples of 9 look like?
18.
So 9, 18.
27, 36, 45, 54.
Etc., right? And we just keep going on and on and on, as long as we needed to.
Yeah.
What about a list of multiples of 12?
12, 24, 36,
48.
60.
Etc., on and on and on, right? Okay, and so we would just, on this list of multiples, we just want to find the first common multiple. Well, there it is. 36 appears on both lists, right? And being as that's the first common multiple, that's the least common multiple, right? So then all we have to do is we know right away, we know that we want to get 36 in the bottom of each of these two fractions that we're adding up, right? And if we do that, then we can write that as one big common, a common denominator of 36, where we can just have one shared denominator, and then we can add or subtract all the numbers on the top. Does that make sense? You remember doing stuff like this. Okay, so with this first fraction then, 2/9, what do we need to multiply the bottom by to get 36? 4. Okay, but that means we also have to multiply the top by that, because all we're really going to do is we're going to multiply by 1 in the form of 4 over 4. Think why we multiply by 1. If we multiply a number by 1, we're not changing its size, right? It stays the same number, but because it's a 4 over a 4, we're just changing the numbers on the top and the bottom of the fraction. But the overall fraction stays the same, right? So 2 times 4 gives me 8, right? So the first fraction just becomes 8 over 36. What about the second fraction?
3 over 3.
3 over 3, good. So that's going to give us 21 over 36. And so we end up then with our final answer being 8 plus 21 is just 29, 36, right? No big deal, okay? Easy, easy, easy. There is another way to do this. Let's look at the same problem in a slightly different way. Another way we could do this is we could say, let's go ahead and completely factor both of the denominators. Okay, and let's start with that. So if we take 9, what is 9 equal to in factored form? Completely factored form. Yeah, it's just a 3 times a 3, isn't it? So there's 9. Okay, what about 12?
4, 3, 2, 2.
3 and 4, and then the 4 breaks up into a 2 and a 2, right? So we get 3 times 2 times 2. If we write those in increasing order of the factors, 2's come first, so we get 2 times 2 times 3. What's another way of saying 2 times 2?
4.
Well,
2 squared.
2 squared. So another way of writing that would be just to say 2 squared times 3, right? Either way, that's what we get, right? 3 times 3 or 2 times 2 times 3. Now what we want to do with this is we want to come up with the, oh darn it, I don't want to do that. We want to come up with the shortest list of factors. Yes, sir.
Couldn't on 9 it be 3 squared or?
Yeah, sure, it could be 3 squared. Yeah, absolutely. And we could write this if we wanted to as 3 squared. No, that's a good point. Okay, so now what we want to do is we want to take all this stuff and we want to come up with the shortest list of factors that satisfies both the 9 and the 12, both of the denominators, right? So we want the list, it has to include, it needs to be a list that's inclusive of those factors and those factors. But we can share factors sometimes, right? So what would that list be? What would that be?
2.
I'm gonna need the denominator 9. It has to have, in this list, I have to have at least 2 factors 3. The factor 3 has to appear twice. For the 12, the factor 2 must appear twice, and the factor 3 only needs to appear once.
Wow.
Yeah, that's it. So we're gonna get 2 times 2. So there's a 2 and there's a 2, and I need them because of the factor 12 times a 3 that's shared between both, and then an extra 3 that we need for this one. Everybody see that? So we end up with, from the yellow perspective, all we really needed here was those 2 factors. From the green perspective of the 12, we needed those 3, and so the 3 overlaps. It's a shared factor. But the shortest list I could produce that would include at least 2 3s and at least 2 2s and 1 3 is 2 2s and 2 3s, right?
Oh my God.
Are you getting this?
All that multiplied together equals 36.
How about that? Yeah. So then if we take if we take these 2 fractions, this first one we're going to write as 2 divided by, let's say we're adding these up, right? So if we're summing these 2 up. The 9 is written as a 3
That's the ideal.
times a 3 plus the 7 is over a 2 times 2 times 3. In order to have this complete list on the bottom, what would I have to multiply the left fraction by?
Wait, what?
Shoot.
Oh,
I don't know.
Like, look right here, I've got a 3 times a 3 on the bottom. If I want to have this list, 2 times 2 times 3 times 3, that's my least common denominator, what would I have to multiply the bottom by in this first fraction?
2.
2 times 2, right? Everybody agree? I need 2 2's on the bottom, so a 2 squared. So I got to do the same thing to the top. We'll just call it a 2 squared, right? Okay, what about this guy over here?
You got times by another 3.
By another 3. Because I need, once again, I need all 4 of those factors in the bottom. So I'm going to multiply top and bottom by, 3, right? And then what do you notice? Well, we end up with, this just equals 8. 2 times 2 is 8 over 36 plus 21. over 36 gives us our answer of 29 over 36. So there's another method, right? The other method is we need to make sure that we're going to multiply by just enough small factors to get the factored form of the least common denominator. Which one seems easier to you?
The first one.
First one, I'd say so too. First one, definitely. So why did I show you the second one? Well,
Because we need to know.
you need to know, and here's why you need to know. What about a problem like that?
Plug and shut.
Okay, so on a problem like this, now if I have very large denominators where it's not obvious, I do not want to make a list of multiples.
No.
The list of multiples could be really long. I mean, if I get two large numbers like this, it might be that the first time I end up getting a common multiple is when I do the product of those two numbers, which is enormous, right? So the list could have, the list of multiples of 168 could have over 1,000 entries in that list before I find one that works, possibly, right? That's a lot of work. I'm not willing to do that much work for a math problem, sorry, right? So the finding a least common multiple in this case by using a list of multiples is completely out of the question, right? But using, if we just factor the denominators and make that short list, that short inclusive list, it's pretty easy. It's really almost no harder than the last one. It's the same concept. So let's factor 168. Let's factor 168. What's that give us if I create a factor tree for 168? What's two numbers that multiply to 168?
2 and 4.
Good. Now what?
Louder.
2 and 40.
Good.
40.
Six and seven.
Oh.
I got you, Derek.
2,
I'd
3,
rather
and
say
2
2
and
and
3.
21.
2 and 3.
So we get 2 times 2 times 2 times 3 times 7, right?
Yeah.
So another way of saying that would be 2 to the 1, 2, 3. So 2 cubed times 3 times 7. Good. Okay, what about 1260?
2 and 630.
Oh,
How?
how did you know that?
Well,
We're just cutting that in half.
yeah.
Well,
I don't know how to cut that in half.
All right, let's go.
2.
Let's go.
2
Let's go
and
2, 3, 10, 315.
What? What?
5.
Yeah, it ends in 5, so we could do a 5.
And 63.
What?
Good.
What? Oh, 9 and 7.
9.
Let's do 3 and 3 now.
That's all you can do.
And now we're done. Okay, so what about this one? So now we've got,
2 squared.
good, so we get 2
Anything
squared.
less than 100
Times
I
3
can.
squared.
3 squared, okay, times 5 times 7.
Good. Okay, very good. So now let's just make our list of the least common denominator. So it's got to include, right? We need to have all of the factors of 168 and all of the factors of 1260 in the shortest possible list. So let's see, they both have 2's in them. What's the smallest number of 2's that will work?
2
squares. Third cube.
I need 3 of them for this one, right?
Ah!
So we're going to have 2 cubed. How about they both have 3's in them?
3 squared.
I need 3 squared because this one only needs 1, but this one needs 2, right?
Sure.
Okay, let's see. This one doesn't have a 5, but this one does, so we need a 5.
And then 7.
And they both need only 1 7, right? So there's my list. Make sense?
No.
Okay, it doesn't make sense?
Yeah.
Questions?
Because we have to include like all the small.
Okay, gotcha,
The largest one.
gotcha.
Right?
I don't know.
Does that make sense? So you got to get the shortest list that includes all of those and all of those, but they can share,
Yeah,
right?
the sharing.
Okay.
I was just thinking
Sharing is caring in math too. So.
Yeah.
Let's see. So 168 we know breaks up into, so this works out to be a 2 cubed times 3 times 7. So let's figure out now. What do we have to multiply both the top and the bottom by here?
A 2.
So let's see, we've already got
Oh, yeah,
3
we got
2's.
So I need a 3
I need a 3
and a 5.
and a 5. Everybody agree?
Yes.
Okay, how about over here? The 13, we've got,
Wait, why do you have to multiply by 3 and 5?
because I need a 3 squared, I need 2 3s, and I only started off with
Oh,
1.
there's only 1. Okay, gotcha. And then
Right.
you need 5 for the bottom one.
There you go. Yeah, I needed a 5 because this one had a 5, but didn't start with a 5, right?
Okay, yeah.
So 1260, here are the factors of 1260. So we have 2 squared times 3 squared times 5 times 7. So what do we need to multiply by there?
3, 2.
Just a 2 it looks like. Everything else, I've got my
Oh,
2 3s and my 5 and my 7, but I only have 2 2s and I need 3 2s for my LCD. So we'll multiply the top and the bottom each by 2. And that's not so bad, right? Then that just gives us, if I multiply that out,
25.
Okay, so,
go ahead.
30, I don't know.
33 times 5 would just be 165.
Yeah.
And 13 times 2 is 26. And so we end up with something like that, right?
Wow.
Yep.
We get 165 plus 26 over my common denominator. If I multiply all that stuff out, we never actually did that on the last page. What does this whole thing equal?
25, 20.
2520, it turns out, yeah. If I multiply all that out, I get 2520. That's my least common denominator. That might have been, in this case, the list wouldn't have been that long, but you can imagine that that could be pretty bad, right? But this way we go right to it.
Yep.
Okay? So we end up with 165 on the top of the first one, 26 on the top of the second one. We add up those numerators over my common denominator of 2520. We get 191 over 2520. No big deal, okay? So now let's try the same concept but with algebra,
Ooh.
okay?
Yeah.
All right, so this time-
Well,
This time let's start off with my first denominator is just an x, right? So let's write the x in factored form. Well, x, it's not too exciting, it's factored. Okay, the next denominator is 4x plus 12. So I've got to break that apart as far as I can. Now there's only 2 terms, right? So there's no fancy magic numbers here. The only thing I could do is possibly factor out a common denominator. I mean, factor out a greatest common factor, right? Undistribute, in other words. What'd you say? 4, good. So we can pull out a 4,
yeah.
and then this would equal 4 times what?
3.
Well, I got it undistributed for both. X
Times 3.
plus
Plus.
3, okay. So then my least common denominator would have to be the shortest list that it has to include the factor x, and it has to include the factors 4 and x plus 3. Well, they don't share any, do they?
No.
So it's just going to be x times 4 times x plus 3, right? What we want to do, though, if we have constants, like numbers, we want to put the numbers out in front. That's just kind of a bookkeeping thing. It makes it easier to keep track of. So we'll put the 4 out front times x plus 3. That's it. That's the least common denominator, right? Okay? It's no big deal, right? Let's try another one. Shannon, why don't you put that away? Let's try this one. Let's look at this. So here I've got one factor. Whoops, wrong color. Got one factor. I gotta stick to my color scheme. I was happy with my color scheme. So we've got the factor 3x squared minus 21x plus 30. Okay, so let's try to break this thing apart. First of all, we always want to see if we can undistribute first. You see a number I could undistribute. I can't take an x out because this term doesn't have an x.
3.
Yes, I could factor out a 3, couldn't I? So that's going to leave us 3 times what's left over.
X squared
Good.
minus 7.
X, good.
Minus 10. I mean plus 10.
Good, okay. And so let's go one step further then. We've got a 3. Now can we find magic numbers? Can we break this quadratic expression, can we break that apart into 2 smaller pieces?
2.
Okay, so I've got x there and there. What are the numbers again?
-5.
You said -2, -5?
Yeah.
Good.
Gotcha, Derek.
Okay, so there's the list from the first denominator. Right, now let's take the second one. Let's try this guy. So we've
Yeah.
got 6x squared minus 150. Can I undistribute?
Sure.
Yes.
I can.
3.
3. Okay, let's do a 3. So if I take a 3 out, I'm left with 2x squared minus 50.
Oh, yeah.
Okay, can we keep going?
If we want to.
Anything else we can do?
I don't know.
What else we got? Can we keep going? Can we undistribute something?
No.
2.
I could take a 2 out, couldn't I? Couldn't I also pull a 2 out?
Yeah.
Oh, sure.
Right? So it turns out I could have taken a 6 out the first time. That's all right, though. I can do it in small steps if I wanted. So if we pull a 2 out front, then does everybody see this is just going to become
Yeah.
3 times 2, which is just 6,
Yeah.
times what's left over if I undistribute a 2?
Negative. Oh,
X
X.
squared.
Minus
25.
10.
Right? Okay, so far we've got 6 times x squared
Minus 25.
minus 25. Now we're going to see if we can go further with the x squared minus 25.
You can.
What is that?
You can.
3. Oh, awkward.
You can take an
Five.
X out. 6x
X
minus 25.
Now I can't take anything else out because this one doesn't have an x in it, right?
Well, neither did the other one, and you still did it.
I mean, you're right, but I took out a number. But now there's no number to take out of this one, right?
Yeah.
Okay, but this is a pattern. This is an easy one. Which pattern is that?
Ooh, X.
X squared,
A
AX
minus B.
So that fits the pattern of difference of squares, doesn't it?
Yeah.
So if I have something that fits that pattern, let's write that pattern down up here. Difference of squares, a squared minus b squared equals what?
A plus B
Times.
A minus B.
Okay, and this one looks like x squared minus what squared?
5 squared.
Ah, okay. So what's it equal then?
X plus 5.
X minus 5. Good. Okay, so then we end up with, for our green factored form, we're going to get 6 times x minus 5 times x plus 5.
Yes.
Right? So now we want to find the shortest list that's going to include all 3 of those yellow factors and all 3 of those green factors. Are there any shared?
Yes.
X
Yeah, there are.
Yeah.
There are. And really the 6, we should break the 6 down. You know, I kind of did something a little bit dumb here. So the 6, we want to have this completely factored, so I shouldn't have multiplied those together to make a 6. We should just leave it as 3 times 2, and then it's easier to see.
Then you can cancel the 3. Right?
So we don't really cancel, but what we see is that we share 3's and we share x minus 5's, right? So when we make our list of the least common denominator, what's it going to be? Well, let's do the number part first
Wait, for which one?
for the yellow and the green, because those are the denominators, right? I'm trying to find the least common denominator of these two things. So the number part is I have to have at least a 3 in this one and at least a 3 and a 2 in this one. So I need 3 and a 2, don't I?
Yep.
Right? 3 times 2. What about the variables? Well, this one needs an x minus 2 and an x minus 5,
And then x plus 5.
and then an x plus 5. Good. So we end up with x minus 2 times,
X minus 5. And x plus 5.
good. And if we kind of look at where those come from, well, the yellow ones are these. Right? The green ones are these. So they do share a couple, right? But that's my list. Make sense? Okay, so why do we do this stuff? Well, we do it because we're adding up fractions, so let's try that. Let's try adding up these two fractions now.
We ran.
So these are rational functions. They've got variables on not only, I mean, in this case, they're all on the bottom. Usually they would just be on the top, right, for the stuff we've done in the past. Okay, so if we're gonna add these up, we gotta get a common denominator. So let's break these into parts. Let's take this guy, the only factor in the bottom of that fraction, the denominator is x. What about this one right here?
X minus 2 plus, minus 2x.
X minus 2 times x, right, as I think I heard, right?
Yeah.
Okay, so then what's my list gonna be?
X.
X times
X.
x minus 2, good.
Yeah.
Okay. So then all I've got to do is I've got to get that list on the bottom of each one. So let's take the first fraction. So the first fraction looks like -5 over x. What do I need to multiply that one by on the
X
top and the
minus-
bottom?
X
Minus
minus
2.
2.
In
Good.
parentheses.
Good. And then the other one is actually already done, isn't it?
Correct.
Okay. And so I know then that I'm going to get a common denominator of x
Squared.
times
Oh.
x minus 2, which is just x squared minus 2x. What shows up on the top? Well, on the top, we can take all this stuff, right?
5x minus 2 plus 6.
Everything that's going on other than the denominator, we can just group together in the top then. So we get -5 times
Plus 10. Oh,
x minus 2 plus 6. And now all we have to do is just simplify at that point. No big deal.
So, negative 5x plus 10, or plus 16.
Good. So on the top,
5x plus 16.
good, we get negative
5x
5x
plus 16.
minus 10. Oh no, plus 10, sorry. Plus 6 is plus 16. Very good.
Over
and on the
x
bottom-
squared minus 2x.
Yeah, x squared minus 2x. There we go. How about that? Okay, make sense?
Yep.
Okay, try one more.
Okay.
Let's try to skip forward. How about something like that guy?
You just make it harder.
A little bit harder.
Alright, so we got 9.
9x.
Yeah,
Wait,
let's
no.
make our list of the denominators. So we got 9x
X.
squared minus 4. Now, that one, there's no common denominator, there's no common factor, is there?
No.
Okay, but what pattern does that fit?
A squared.
Ah, yeah, it does, doesn't it? It fits a difference of squares.
Yep.
So what's the second thing that's squared? 2. What about the first?
3.
3x, aha. So that one must equal then, what?
X squared. No, wait, what? Oh, 3x.
3x plus 2,
2.
3x minus 2, right? It's gonna be a, that's a and that's b, so it's a plus b times a minus b, right?
Yep.
Okay, what about the other one? We get 3x squared minus 2x.
Oh,
Can I factor anything out?
no.
Agrees. X.
I can't take any numbers out, but they both have variables, right?
X equals X.
So what can I undistribute?
X.
X, yeah. What am I left with?
3. X. Minus 2.
Minus 2. Okay, so here we go. So this is my factored form of the first denominator, and this is my factored form of the second. Do they share any?
3x minus 2.
Aha, they share the 3x minus 2, don't they? Right?
Yep.
So then my LCD would be what?
3x plus 2. And 3x minus 2. And x squared.
And an x, right?
Yep.
Okay, because I have to have at least one x and at least one 3x minus 2 from the green. Okay, well that's done. There's my x, there's my 3x minus 2. And from the yellow, I need one 3x plus 2 and one 3x minus 2. Right?
Yep.
Okay, so if we go back down here then, we've got our 6 over the yellow, that was yellow, right? So that worked out to be those two, so.
3x plus 2, 3x minus 2.
Good, so we're gonna multiply that one by what then? If I have to get the blue, by x, good. So we'll multiply this one by x over x, right? Minus, now notice we got a minus sign.
Minus 3,
3 over,
and then x, and then 3x plus 2 is 3x minus 2.
and I need to multiply top and bottom by which one then?
3x plus 2.
3x plus 2. Okay, good?
Yeah.
And so we end up with then what? So on the top, we're gonna end up with, on the bottom, we're just gonna end up with that whole thing, right? And we'll multiply it out. Yeah. So, okay, we'll just leave it like that for now. But on the top, what are we gonna get? So we're gonna get 6x
6
minus
minus
3 times the quantity 3x plus 2. So that's
Okay,
gonna
so
give
6
us,
plus 9 is 15, right?
okay, so 3 times 3x is
9.
9x, so I'm gonna get 6x minus 9x.
So,
And then 3 times 2 is 6, but I'm subtracting that, right? So minus 6. And now we can just simplify that and we're done.
negative
So on the
3x
top, yeah, 6x minus 9x is negative 3x minus 6, good. And then on the bottom, what are we gonna get? Well, we know that, we could be a little bit smart about this. We know that 3x plus 2 times 3x minus 2. So this part right here equals 9x squared minus 4, right? So all that stuff just becomes 9x squared minus 4. If I multiply that times x, what's it gonna do?
cubed
Yeah, I'm just gonna end up with a 9x cubed
minus 4.
minus 4x, exactly. There it is. That's our answer. Okay. Make sense?
Yep.
Okay, have at it. You have a little bit of time. Grab a Chromebook.
Can I go back?
Yes, you may.